Lesson 11.2, Task 5. Model with simple rational functions. When a real-world situation involves both a shared cost and a per person or per item cost, you can model the situation using a rational function of the form g of x equals a over x plus k. In this model, g of x is the cost per person or per item, a is the shared cost, and x is the number of people or items that share the cost A, and k is the per person or per item cost. A group of friends is traveling to see a concert in a nearby city. Each person will pay for their own ticket, and the group will split the $20 cost for gas and tolls. How many people need to travel together for the total cost per person to be at most $44? All right, so each person is going to pay for a $40 ticket. They're going to have a group share the cost of gas and tolls, which is a total of $20, and each person wants to pay at most or no more than $44. That means less than or equal to 44. All right, so to think about the information given, we have a total cost per person for the ticket is $40. The cost of gas and tolls to split by the group is $20, and each person will pay a maximum of $44 or 44 or less. All right, so write a function. Let P equal the number of people who go to the concert and C of P be the total cost per person. Drag the terms to write a function for the total cost per person. All right, so if the total cost per person is C of P, we can put C of P in the first blank here. C of P equals cost of gas and tolls divided by the number of people. So gas and tolls is going to be $20 divided by P, the number of people. So this will be 20 divided by P. And then the cost of the ticket. Each person has to pay their own ticket, which is $40. All right, then it says, graph this rational function in the horizontal line representing the maximum cost per person. C equals $44. So that's the most they want to have to pay. So we want to find out where it would work to where they don't have to pay more than $44 each. All right, so you're only going to have to graph in the first quadrant. All right, if you look here, they have graphed this for us. And this is the horizontal line at 44 because they don't want to pay more than $44. And then here's our graph C of P, okay? All right, it says the two graphs intersect at 5 and 44. The graph of the function C of P for the total cost per person is on or below the line C equals 44 and P is greater than or equal to 5. This means that at least 5 people need to go to the concert in order for the total cost per person to be $44 or less. So again, you can see here is the number of people, and here's the total cost per person. And when this gets to this line, these two lines intersect, and that means 5 people. If 5 people go, then they only have to pay $44. If less than 5 people go, their cost would be more because the shared cost would go up. All right, so it says Emmett thinks that the function given the total cost per person should be C of P equals 20 plus 40 over P, or C of P equals 60 over P. How would you explain to Emmett why this function is incorrect? All right, so if this was the function that would work, that would show that you're only paying for one ticket and that the whole group is going to share the concert ticket price. And that's not true. So you're sharing the price for gas and tolls, but each person has to pay the $40 separate for their ticket price. All right, it says, can the total cost per person ever be $40? All right, so it says the ticket alone costs $40. So the only way that each person would pay $40 is if they walk to the concert and they don't have to pay gas or tolls. If they drive to the concert, no matter how many people go, they're still going to have to split that cost. And even though if a lot of people go, that could become a low cost, but it would still be more than $40. So the answer to this would be no, not unless they walk and don't need gas or tolls. And who knows how far the concert is, so I don't know if that's reasonable. Let's see what they say. No, the total cost per person is $40 for the ticket plus each shared cost. So basically the same thing. All right, can the total cost per person ever be $46? All right, well, let's see. We're given a function. Let's see if it can be $46. So let's go back up here. Okay, so we wrote a function here. And we have C of P equals 20 over P plus 40. We want to know, can ever be $46? So if we subtract 40, so that's going to be 6 equals 20 over P. Let's divide or multiply both sides by P. So we've got 6P equals 20. Divide by 6. So P equals 3 2/3. So P represents the number of people. So is it logical to have 2/3 of a person go? And the answer to that is no. So the question to this one, or the answer to this question here, can the total cost per person be $46? No, it can't be $46 unless you can have 2/3 of a person. So 3 2/3 is not a reasonable answer for number of people. So you can never be charged $46 to go. Let's see again what they say. All right, no, the graph intersects the line C equals 46 at the point 3 1/3. Oh, they got 3 1/3. Maybe I did something backwards. Oh, I did. 18 leaves 2 over 6. 2 over 6 is 1/3 instead of 2/3. All right, that is 1/3. Still can't have 1/3 of a person. My pen's not working, so just be aware that that should be a 1/3. Let's see if it'll work here. There we go. All right, so that is not possible. If you have any questions, please let me know.